We were very encouraged in the changes we've seen since really the first year of applications and technology in its current form. We had something like a 50% increase in papers submitted to the conference, at least to our subcommittee. And I think that's a sense of word getting out that CLEO is now much more drawing on these applications area, lasers getting out of the lab and into the hands of real end users. And so the quantity is one thing. The quality is also up this year. If we look at the scores that the committee scored for those papers contributed, they were significantly up on last year also. The subcommittee that I chair, it's very interesting because we have this huge diversity all the way from very small device type applications right through to huge laser systems that are used in facility class instruments. So a great example there would be we have a tutorial which is going to be presented by Professor Roger Falcone from Lawrence Berkeley Lab. And he's really talking about what's termed the advanced light source, which is a synchrotron-based source and can generate laser light at a huge range of wavelengths. And so he's really going to be describing the capabilities they have there and all the science that's being enabled by that device, which spans a massive range, everything from materials, very precise materials processing at one end, biomedical down at the other end, capabilities getting into the soft X-ray region that you really just folks don't have access to in other places. And then if you want to, so that's really an ultrafast laser source. If you want to look at ultrafast in a different context, we have an invited paper by Mike Mielke from Radiance. And Radiance is making commercial ultrafast lasers, very compact ones based on fiber technology. So that's ultrafast technology not in a large institution, but actually being packaged and sold for materials processing, dentistry, medical type applications. And so in one area, in that case ultrafast science, and we have a whole session on ultrafast applications, you're really getting a massive difference, range of applications and types of technology. In another session that we have, we're focused on instrumentation and remote sensing. So sensing in all kinds of ways, with a common element being standoff. So it can be a few meters away from the laser source, or it could be kilometers away, or even further for space type sensing, where the instrument would be in space. And the rest of that session is made up of some really clever things that are emerging from the lab in the way of instrumentation, ways of doing different kinds of sensor capabilities that could be implemented in the medical space, or again in materials processing, or in the government type security applications. One other really interesting talk we have is Professor Fujita at the University of Osaka, and he's talking there about lasers being implemented really in remote sensing there of industrial processes, pretty heavy industrial processes. So that's an academic in that case, but again it's, applications is kind of on the cusp of things coming out of the laboratory and into the commercial and applications space.